Chapter 9B, Lesson 1D, the final one. It took 4 sessions of this to finish the entire lesson. What I'm going to show you here is if I give you a series, if I give you a function, f of x equals the cosine of 2x, and ask for a power series, what you need to say is, wait, I have memorized a series for the cosine of x, which is 1 minus x squared over 2 factorial plus x to the 4th over 4 factorial minus dot dot dot. The nth term, negative 1 to the n, x to the 2n over 2n factorial plus dot dot dot. So now if I want to find a power series for the cosine of 2x, I simply need to plug this 2x in for x. So 2x squared over 2 factorial plus 2x to the 4th over 4 factorial minus dot dot dot, negative 1 to the n, 2x to the 2n over 2n factorial. I don't know if you noticed in the last lesson, part C, when I wrote the sine of x, I wrote it over n factorial, and it should be over 2n plus 1 factorial. I don't know if you noticed that. The next one here, g of x equals e to the 5x. Again, you must have these committed to memory, so this is going to be 1 plus x squared over 2 factorial plus x to the 3rd over 3 factorial plus dot 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 plus x to the n over n factorial plus dot dot dot. Pretty easy one to memorize here because every derivative is 1, and so the coefficients are 1 in front of every single term, and it fits the Maclaurin series. Maclaurin meaning it is centered at 0. We will focus on the Taylor series in lesson 2. Okay, so we have that established. So e to the 5x, then we are going to substitute 5x in everywhere we have x. Dot 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 5x to the n over n factorial, and I'll let you simplify that. Here we have the sine of x again, the one that you should commit to memory, the series for that which converges for all real x. The cosine, the derivative of that, also converges for all real x. So what I'm going to ask you to do here is we're going to approximate the sine of x, approximately, using a polynomial. Watch the notation, a polynomial of not degree 7, but order 7. Now, most of the time the degree and order are the same, but order actually means how many derivatives. So if you take the 0th derivative of sine of x, meaning not the derivative of all, at 0, sine of 0 equals 0. The first derivative, which is cosine at 0, is 1, and that's why we have a 1 here as a coefficient, as we established in part B. So what I want to do is go out order 7. This would be order 1, 2 is 0, order 3, 4 is missing, order 5, 6 missing, 7. So a polynomial which approximates the sine of x, really important that you write approximate if you're going to use a polynomial, x minus x cubed over 3 factorial plus x to the 5th over 5 factorial minus x to the 7th over 7 factorial. Period. That's the end. There's no plus dot dot dot. That is it. That's it. That's it. That's it. That's a polynomial approximation to the sine of x. Here we have the cosine of x, and I'm going to ask for the 4th order polynomial approximation. So the cosine of x is approximately a 4th order polynomial. Order 0 is going to be 1, order 1 is going to be 0, order 2 coefficient is going to be a negative 1, order 3 missing, order 4. See how it's matching up with the degree. So this is a fourth order, also a fourth degree polynomial that approximates the cosine of x. If I ask you for a fifth degree polynomial, well, it looks like this, x to the fourth or 4 factorial. But the fifth order, which is going to be the sine of x at 0, is 0. There is no term here, plus 0. So the polynomial of order 4 is equal to the polynomial of order 5. And this also illustrates that this is order, not necessarily degree. But what we do is if the nth order is 0, we just bring it back down to the order that matches so that the degree matches the order. So, okay, that concludes all the lesson. I'm going to put the homework on this in case you have missed class and you need it. So give me one moment. Okay, so the homework on page 483, I would like you to complete 55, 57, 59, 72, 63, and 64. Pardon me for putting them out of order. Also on page 492, I would like you to complete 3, 5, 7, 10, 12, 22, 24, 27. Notice, you will notice that these are all Maclaurin series. What a Maclaurin series means is, again, it's centered at 0, so that we have f of x equals f of 0 plus f prime of 0x plus f double prime at 0, x squared over 2 factorial plus dot 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 plus f nth derivative at 0 makes it Maclaurin at 0, x to the n over n factorial dot dot dot. That's what makes it Maclaurin. We haven't really dealt with any Taylor. Again, that's going to be for the next lesson, lesson 2. In addition to all of this, I noticed some multiple choice, 37 to 40 from this same page here. You will also see on page 491 a list of the Maclaurin series that you should memorize. One for the sine of x, cosine of x, inverse tangent of x, and e to the x. You should also have committed to memory the interval of convergence for each of those. That is the end of the lesson. I'm sorry for those who missed class. Hopefully this is not too much. Goodbye.